Dopamine is what we call a neuromodulator. Neuromodulators are different than neurotransmitters. Neurotransmitters are involved in the dialogue between neurons, whereas neuromodulators influence the communication of many neurons. In the nervous system, what this means is that dopamine release changes the probability that certain neural circuits will be active and that other neural circuits will be inactive. So how does dopamine work and what does it do? Well, first of all, it is not just responsible for pleasure. It is responsible for motivation and drive, also for craving. Those three things are sort of the same: motivation, drive, and craving. It also controls time perception. This turns out to be important to not end up addicted to substances, but it also turns out to be very important to sustain effort and be a happy person over long periods of time, which I think most everybody wants. Dopamine is also vitally important for movement. I'll explain the neural circuits for dopamine and mindset and dopamine in movement in a moment. But in diseases like Parkinson's or Lewy body's dementia, which is similar to Parkinson's in many ways, there's a depletion or death of dopamine neurons at a particular location in the brain, which leads to shaky movements, challenges in speaking, challenges in particular in initiating movement. And because dopamine is depleted elsewhere, too, people with Parkinson's and Lewy body dementia also experience drops in motivation and affect, meaning mood. They tend to get depressed and so on. When those people are properly treated, they can recover some fluidity of movement, some ability to initiate movement, and almost without question, those people feel better psychologically, not just because they can move, but also because dopamine impacts mood and motivation. So what are the underlying neural circuits? You have two main neural circuits in the brain that dopamine uses in order to exert all its effects. One mainly for movement, right? This is the substantia nigra to dorsal striatum. And we've got this other pathway, the so-called mesocortical limbic pathway, that's for reward, reinforcement, and motivation. Now, the other thing to understand about dopamine is that the way that dopamine is released in the brain and body can differ. There's local release, what we call synaptic release, and then there's volumetric release. So volumetric release is like dumping all this dopamine out into the system. So dopamine is incredible because it can change the way that our neural circuits work at a local scale and at a very broad scale. So if I were to just put a really simple message around dopamine, it would be there's a molecule in your brain and body that when released tends to make you look outside yourself, pursue things outside yourself, and to crave things outside yourself. Dopamine is a universal currency in all mammals, but especially in humans, for moving us toward goals. And how much dopamine is in our system at any one time compared to how much dopamine was in our system a few minutes ago, that dictates your so-called quality of life and your desire to pursue things. This is important. Your experience of life and your level of motivation and drive depends on how much dopamine you have relative to your recent experience. This is why when you repeatedly engage in something that you enjoy, your threshold for enjoyment goes up and up and up. So I want to talk about that process, and I want to explain how that process works, because if you understand that process and you understand some of these schedules and kinetics, as we call them, around dopamine, you will be in a terrific position to modulate and control your own dopamine release for optimal motivation and drive. While most experiences and most things that we do and take and eat and et cetera won't create enormous highs and enormous lows in dopamine, even subtle fluctuations in dopamine really shape our perception of life and what we're capable of and how we feel. And so we want to guard those and we want to understand them. All of us have different baseline levels of dopamine. Some of this is sure to be genetic. Some people just simply ride at a level a little bit higher. Some people are a little less excitable. What dopamine does is dopamine really colors the subjective experience of an activity to make it more pleasurable, to make it something that you want more of. So what sorts of activities, what sorts of things increase dopamine? And how much do they increase dopamine? Well, let's take a look at some typical things that people do out there or ingest out there And let's ask how much dopamine is increased above baseline. Chocolate will increase your baseline level of dopamine 1.5 times. Okay, so it's a pretty substantial increase in dopamine. It's transient. It goes away after a few minutes or even a few seconds. Sex, both the pursuit of sex and the act of sex, increases dopamine 2 times. Nicotine, in particular nicotine that is smoked, like cigarettes and so forth, increases dopamine 2.5 times above baseline. It is very short-lived. Cocaine will increase the level of dopamine in the bloodstream 2.5 times above baseline. And amphetamine, another drug that increases dopamine, will increase the amount of dopamine in the bloodstream 10 times above baseline. A tremendous increase in dopamine. Exercise. Now, exercise will have a different impact on the levels of dopamine depending on how much somebody subjectively enjoys that exercise. So if you're somebody who loves running, chances are it's going to increase your levels of dopamine 2 times above your baseline, not unlike sex. People who dislike exercise will achieve less dopamine increase or no increase in dopamine from exercise. And if you like other forms of exercise like yoga or weightlifting or swimming or what have you, again, it's going to vary by your subjective experience of whether or not you enjoy that activity. This is important, and it brings us back to something that we talked about earlier. Remember that mesocorticolimbic pathway? Well, the cortical part is important. The cortical part actually has a very specific part, which is your prefrontal cortex, the area of your forebrain that's involved in thinking and planning and involved in assigning a rational explanation to something and involved in assigning a subjective experience to something. So certain things, chemicals, have a universal effect. They make everybody's dopamine go up. So some people like chocolate, some people don't, of course, but in general it causes this increase in dopamine. But sex, nicotine, cocaine, amphetamine, those things cause increases in dopamine in everybody that takes them. Now, I've been alluding to this dopamine peaks versus dopamine baseline thing since the beginning of the episode. Now let's really drill into what this means and how to leverage it for our own purposes. In order to do that, let's take a step back and ask, why would we have a dopamine system like this? Why would we have a dopamine system at all? Well, we have to remember what our species' primary interest is. Our species, like all species, has a main interest, and that's to make more of itself. And it's not just about sex and reproduction. It's about foraging for resources. Resources can be food, it can be water, it can be salt, can be shelter, can be social connection. Dopamine is the universal currency of foraging and seeking. Right? We sometimes talk about motivation and craving, but what we mean in the evolutionary adaptive context, what we mean is foraging and seeking water, seeking food, seeking mates, seeking things that make us feel good and avoiding things that don't make us feel good, but in particular seeking things that will provide sustenance and pleasure in the short term and will extend the species in the long term.